New construction today uses stronger concrete, engineered lumber, advanced steel systems, high-performance insulation, modern sealants, and smart building technologies. On paper, modern buildings should outperform older structures by a wide margin. They are designed with better calculations, improved materials, and advanced tools that previous generations never had access to. Engineers can model loads more accurately, architects can simulate performance, and manufacturers can produce materials with tighter tolerances and higher strength. Yet despite all of this progress, many newly built homes, commercial buildings, and developments begin to fail far sooner than expected. Cracks form in walls and foundations, water leaks through roofs and basements, mechanical systems underperform, and expensive repairs start within just a few years of completion. In some cases, these problems appear even before warranties expire, leaving owners shocked at how quickly issues surface in brand new buildings. This creates frustration and confusion for owners, investors, and even builders themselves. The expectation is that new construction should be reliable, durable, and low maintenance for decades. Instead, many people discover that new buildings often come with just as many problems as older ones, and sometimes even more. This raises a serious question that deserves a real answer. If materials are better than ever, why does new construction still fail? The truth is uncomfortable but clear. Construction failure is rarely caused by materials alone. In most cases, materials perform exactly as designed when tested in isolation. The real failures occur in the systems surrounding those materials. Buildings fail because of decisions made early, pressures applied throughout the project, and compromises that quietly weaken the structure long before problems become visible to occupants. One of the most significant contributors to failure in new construction is poor early-stage planning. Many projects start with aggressive schedules and tight budgets that leave little room for thorough analysis and verification. Soil conditions may not be fully evaluated. Drainage patterns may be assumed rather than tested. Environmental exposure may be underestimated or oversimplified. When planning prioritizes speed and cost over accuracy and resilience, risk is built into the project from the very beginning. These early decisions often affect the foundation, which is the most critical part of any structure. Skipping detailed soil testing can lead to uneven settlement that slowly stresses the building frame. Underestimating groundwater levels can cause long-term moisture intrusion and hydrostatic pressure against foundation walls. Inadequate foundation design may technically meet minimum code requirements but still lack long-term durability. These problems rarely cause immediate failure. Instead, they create slow, progressive damage that appears months or even years later. Another major reason new construction fails is improper installation. Modern materials are highly engineered, but that also means they are far less forgiving than older materials. Waterproofing systems, insulation assemblies, vapor barriers, sealants, and structural components all require precise installation to perform as intended. If even one step is done incorrectly or rushed, overall performance drops significantly. For example, a waterproofing membrane installed with small gaps, poor overlaps, or inadequate adhesion may appear fine at first. Over time, moisture inevitably finds its way through those weak points. Insulation that is compressed, misaligned, or poorly sealed loses thermal performance and creates condensation risks. Structural connectors that are improperly fastened reduce load capacity and weaken the entire system. These errors are often hidden behind finishes, making them difficult to detect until damage becomes widespread and costly. Concrete is another area where installation quality matters more than material quality. High-performance concrete depends on correct mixing ratios, proper placement, adequate vibration, sufficient curing time, and environmental control during curing. If concrete is poured too quickly, allowed to dry unevenly, exposed to extreme temperatures, or cured improperly, internal weaknesses form. These weaknesses may not show immediately, but they reduce long-term durability and increase cracking, scaling, and deterioration over time. Labor shortages have made these issues worse across the construction industry. Skilled trades are in short supply, and many construction projects rely on less experienced workers to meet deadlines. Inexperienced crews may not fully understand the systems they are installing or the long-term consequences of small mistakes. When workers are rushed to keep schedules on track, fatigue sets in and errors increase. These mistakes often remain hidden until the building is occupied and problems begin to surface. Coordination between trades is another major source of failure in modern construction. Buildings today are complex systems made up of interconnected components. Structural framing, plumbing, electrical, HVAC, insulation, fire protection, and finishes must all work together in a precise sequence. When coordination is poor, systems interfere with one another instead of supporting one another. Pipes may be routed through structural elements incorrectly. Electrical wiring may compromise fire ratings or moisture barriers. HVAC systems may be installed without proper airflow balance or access for maintenance. These conflicts are often resolved on-site through improvisation rather than proper redesign. Improvised solutions may function temporarily, but they often reduce long-term reliability and performance. Poor coordination usually stems from weak communication and lack of centralized oversight. When trades operate independently without clear sequencing, leadership, and supervision, conflicts become inevitable. Modern construction requires integration, not isolation. Without integration, even the best materials are forced into compromised conditions that shorten their lifespan. Design decisions also play a significant role in construction failure. Some modern designs prioritize appearance over performance. Large glass surfaces, flat roofs, minimal overhangs, and complex architectural details can create serious durability challenges if not engineered and executed perfectly. These features demand precision, redundancy, and ongoing maintenance to perform well over time. When architects, engineers, and builders are not aligned, design intent may clash with construction reality. A design that works well in theory may be difficult or impractical to execute on site. If issues are not resolved early, builders may make adjustments that weaken performance in subtle ways. These compromises often become future failure points that are blamed on materials rather than decisions. Environmental factors are frequently underestimated in new construction. Climate conditions such as freeze-thaw cycles, humidity, temperature swings, wind exposure, solar gain, and soil movement all affect building performance. Materials that perform well in one environment may degrade quickly in another if they are not properly detailed and protected. Moisture management is one of the most common environmental challenges. Poor drainage, inadequate ventilation, and improper vapor control allow moisture to accumulate inside building assemblies. This leads to mold growth, wood rot, corrosion, and insulation failure. These issues often develop slowly and silently before becoming visible, making them difficult and expensive to correct. Inspection processes are another weak link in many construction projects. While inspections are required, their quality and depth vary widely. Some inspections are rushed or focused only on basic code compliance rather than long-term performance. When problems are missed during critical stages, they become embedded in the structure. Later failures then appear sudden, even though their causes existed from the beginning. Cost-cutting pressure magnifies all of these risks. Value engineering is often used to reduce expenses, but it can be misapplied. Replacing durable components with cheaper alternatives may meet code requirements but significantly reduce longevity. Budget pressure also encourages rush schedules, which increase error rates and reduce quality control across the project. Maintenance planning is often ignored in new construction. Buildings are handed over without clear maintenance strategies, proper commissioning, or adequate training for owners and operators. Advanced systems are installed, but users may not understand how to operate or maintain them correctly. Without proper maintenance, performance declines rapidly and materials deteriorate prematurely. Technology has improved construction, but it has also added complexity. Smart systems, automation, sensors, and controls require proper installation, calibration, and ongoing maintenance. When technology is added without understanding fundamentals, it becomes a source of failure rather than improvement. Documentation and accountability are critical but often weak. Incomplete records make it difficult to trace failures back to their source. Without documentation, lessons are lost and mistakes are repeated across projects. Professionals who succeed long-term prioritize detailed records, inspections, and accountability at every stage. At its core, new construction fails because the process fails. Materials are tools, not guarantees. Without disciplined planning, skilled execution, coordination, inspection, and maintenance, even the best materials cannot deliver lasting performance. Professionals who consistently avoid failure focus on fundamentals. They invest time upfront. They respect environmental conditions. They coordinate trades carefully. They inspect thoroughly. They understand that shortcuts always surface later. Modern construction does not need better materials. It needs better discipline, better systems, and better leadership. When construction is treated as a long-term responsibility rather than a short-term transaction, buildings perform as intended. Strong buildings are not accidents. They are the result of foresight, accountability, and respect for the construction process. Build smarter, plan deeper, and failure becomes the exception rather than the norm. Don't forget to subscribe to the channel for more in-depth construction insights, real-world lessons, and professional guidance on building smarter and avoiding costly mistakes.